Alright, so we are moving on to our last section in Chapter 2, Section 6. Variation and applications is what we're going to be looking at here. So, here we go. Focus mostly on variations. The application stuff is pretty straightforward with these. So, first off, we have what's called a direct variation. So, a direct variation is used for a function of f of x is equal to kx. Okay, and when we say it, we would say that f of x or y, depending on the variables we're using. So f of x varies directly as x increases or decreases. K is our variation constant. So one thing you notice with this is that there's no adding or subtracting when we're dealing with a direct variation. And it's also a linear function. So it's a linear function that starts at 0 and then grows. So this could be something like every hour you work, you make $10. That's a direct variation. You work 0 hours, you get 0 monies. And then if as you work every hour, as you move along, it increases directly. 1 hour goes up by 10, 2 hours is now 20, so on and so forth. That's a direct variation. So a direct variation, there's no adding or subtracting. It's basically a linear function that starts at 0. Okay, and so it's y equals, or f of x equals kx. So, hey, if you got a job at a diner, or you just got a job at a diner, we want to make sure we are a part of this. So, the diner pays you $10 an hour. Write the direct variation for the amount you will earn. What is the variation constant? So, the equation that you have as it goes up, it's 10. So that would be your y, your pay, is equal to 10x. X is the number of hours. The variation constant in this case is going to be 10. That's the k value in this case. Okay, so the k value is what is changing. It's the slope of this curve. Okay, for this direct variation. Okay, fairly straightforward. Again, no adding or subtracting when you're dealing with a direct variation. Okay, so let's make it a little bit more complicated here. So the number of centimeters, W, of water produced when melting snow varies directly as S, the number of centimeters of snow. Meteorologists have found that under certain conditions, 150 centimeters of snow will melt to 16.8 centimeters of water. To how many centimeters of water will 200 centimeters of snow melt? Okay, so this is a direct variation that we're going to be looking at. So first thing we want to do is get our setup with our equation. So our equation would be the amount of water produced from the melting snow, and then it varies directly, so it would be k times the amount of snow that we have. So Ws is equal to k times s. And now we plug in our first set of numbers. So we plug in our first set of numbers. When we have 150 for s, the amount of snow we have, we end up with 16.8. So we plug in 150 in for the s, and then that Ws becomes, or W150 becomes 16.8. And now once we have this set up, we solve for k, divide both sides, and we end up getting our answer of k as 0.112. Okay, so now what would our equation look like? Our equation will look like Ws is equal to 0.112s. That would be the equation of this function. Okay, and that 0.112 is our variation constant. Okay, it's how it's varying. So now we have that equation. Now if we want to find how much snow or how much water we would have after 200 centimeters of snow, we would just have to plug in 200 centimeters into our S to find what W is. And when we simplify it, we find that W is 22.4, meaning that if we had 200 centimeters of snow and we melted it, we'd end up with 22.4 centimeters of water. Okay, that's how our direct variation works. All right, inverse variation. So let's say we have the following. Driving in a car at 10 miles per hour, you want to travel 100 miles. The trip takes blank hours. So if you're traveling 10 miles per hour and you want to go 100 miles, how long is it going to take? It's going to take 10 hours. If the speed is increased to 20, how long is it going to take? It's only going to take 5. It's going to take 5 hours. So the inverse variation for this situation would be t is equal to 100 over r. T is the amount of time, r is the rate or the speed of the car. You take the distance you want to travel and divide it by how fast you're going, and that's going to tell you how long it takes. This is an inverse variation. It's with a division. Again, as you notice, there's no adding or subtracting. So an inverse variation is where you have the k value on the bottom. So the time t required to do a job varies inversely to the number of people, p, who work on the job. If it takes 55 hours for 6 people to build a boat, how long will it take for 9 people to do the same job? So we set up our original variation. So we have t is equal to k over p. K, remember, is still the constant. And now we plug in the numbers that we know. We have 6 people, so that's our p, and then we have 55. So 55 is equal to k over 6. And now it's just going through and solving it. So if we want to solve for k, we'd multiply both sides by 6, getting us our k value as 330, which is our variation constant. And there's our formula. So if that's our formula, and we want to see how long it's going to take for 9 people to do the job, what would we do? We'd plug in 9, and how long will it take for those 9 people to build the boat? That's right. When you divide it through, it should take about 36.6 hours repeating. Okay. So as you see, it takes less time for them to build that boat. Okay. And the more people, the less time it takes. Now these you will hit a kind of a minimum, but it's going to take a while. Combined variations. So now combined variations is where you have multiple variations affecting a single problem. So instead of it not just being direct or not just inversely, you have something else. So it varies directly to the nth power. So the nth power is the key here. That means that your x is going to be taken to some sort of power. Okay, but the k is still constant. The k is never really changed. The k is always just k. You don't put like a 2 in front of it, or you don't square it or anything, because the k is always constant. Y varies inversely to the nth power of x. That means, again, you are putting it to the nth power. So that means it becomes a power. And it's the x that gets hit with the power, not the k. And lastly is jointly. Jointly means that you're going to combine whatever the following 2 variables are, and they're going to be multiplied together. So in this case, y varies jointly as x and z. That means for some positive k, such that that would be y equals kxz. So jointly means that the next 2 variables, or 3 variables, however many they are, they're going to be combined until you have another direct or inverse variation. Okay. All right, so the equation of the variation in which y varies directly to the cube of x, and then we have when y is 45, x is 2. So what we're going to want to do here is that we are going to want to set it up. So since it varies directly, that means we know we're going to have y is equal to kx. Now, it also is saying that it's the cube of x, which means we have to multiply it by 3. Or take it to the 3rd power, not multiply by 3. Take it to the 3rd power. And just the x is being hit with that. Okay. After that, we would end up plugging in the numbers that we know. Y is 45, x is 2. And we go through and we want to find what our k value is, and then rewrite the equation. So find k, and then plug it back into the equation. All right, so when you multiply it through, 2 to the 3rd power ends up getting you 8. So you end up with 45 divided by 8, and that is your k value. So then when you plug it back into the equation, you end up with y is equal to 5.625, which is 45 over 8, x to the 3rd power. And that is our variation. So now, if we have another x or y, we can find the other missing variable. Okay, so find the equation for the variation in which y varies jointly as x and z and inversely as the square root of w. And then we have all these situations with y, x, z, and w. So again, remember we have a k value. So take a second, figure out what the equation would be with this setup. Okay, so we know y varies jointly, so that means we're going to have y is equal to. And then what you can do is you can just take the k and you can just kind of throw the k out front. So you can go, okay, I'm going to have k times something. And then varies jointly to x and z. So that means x and z are going to be multiplied along with it, so it's going to be on top, and then inversely to the square root of w. Inversely means it goes on the bottom. So that means on the bottom you'd go the inversely, which is the square root of w. Okay. Now, when you have that, you end up looking like this. You'd plug everything in. Everything's color coordinated for you. And then you'd simplify it. Okay? Because again, we want to find our k value. So, with this setup, find your k. Okay. So, the k value that you found is, again, 5.625. Just a coincidence for these. And then we would take that k and we plug it back into this equation to find our, we plug it back into this equation to find our formula. Okay, because we need to figure out what that k is. Right. Okay, so that's the end of this section and the end of this chapter for the first chapter 2 of pre-calculus.